every time architect gives us the plan, which is very difficult to construct. So that's why uh, you need to do something good, like which is very helpful in the field of structure. In the structure, we have the basically two parts. First one is analysis, and then second is design. So, which is not audible? Am I audible?
Yes, sir. It is audible.
Yes, Sunil, you can log out and log in again. So it will be audible. Okay. So, coming up to the structure analysis. What is structure analysis? So structure analysis is nothing but you are giving the various loads on the structure. You are defining the combination. Like in the as per Indian standards, we are taking 1.5 to dead load plus live load. Okay. But when you go in the USA, so as per the USA code, they are taking 1.8 into live load and 1.2 into dead load, because the increment of dead load, chances of increment of dead load, is, which are too much less, because dead load is fixed. Although in the India we have the practice take the 1.5 into dead load, but in the USA they are taking 1.2 into dead load and 1.8 into live load. So which software you can use for the analysis of the like this kind of load combination? So you can use the state flow, ETAB. Okay. Same. What is design? So when you are giving the different loads, so you need to construct the structure which can carry the different loads. So you need to give the design to the structure. Like you need to provide the like steel, concrete, grade of concrete, each and everything. It really comes under the structural design. So first we analyze the structure, and then on the basis of analysis, we are designing the structure. Okay, like first we have fixed the plan, line plan, then we will like provide the different loads, then we'll see the response of the structure, like what is the reaction, like what will be the dead load, what will be the live load, what will be the load combination. On the basis of the analysis, we are designing the structure. But when you are doing in the paper, so it will take around 2 days. But when you are doing in the state theory test, it will take only 15 minutes. Yes, 15 minutes, 15 minutes only. Okay. So same way. Yes, Sunil Kumar, do you have any doubt? So same. What are the software used in the analysis? Same software can be used for the design. So if you are working as a structure engineer, what do you need to understand? So our very first step is various agencies involved. Like how many agencies are involved? Like with whom you need to, like with whom you need to do the talk. Now it's audible. Okay, voice is audible to all. Okay, okay, okay. Thank you. So you need to like deal with the client for whom you are constructing. Then you need to deal with the architect who gives us the plan. SBC will be given by the soil investigator. Then construction team, contractor, various service like electrical, plumbing, heating, and acoustics. So it is nothing but the MEP, mechanical engineering plumbing. You will also learn this during the session. Okay, material selection. So owner will contact the architect. Architect will contact structure consultant, MEP consultant, other consultant. MEP is nothing but the mechanical engineering plumbing. Also, owner will consult the civil consultant, geotech consultant, and landscape consultant. They will also contact the architect. Okay, because on the basis of the landscape, civil, and geotech, architect will give the design, and for that design, structural engineer has to like provide the plan, like provide the structural details. Sunil, it is audible for all others. So kindly relog in or check your connection. RCC construction has a different phases: planning, design phases, and construction phases. Under the planning phases, we have the like first architect will give us the preliminary layout. It is not final. Okay. On the basis of if structural feasibility is there, then we say that it is okay. We can go ahead. If structural feasibility is not there, then we can say the architect to revise the plan. Right? Then our next step is to preparation of tender, like how much cost it will take. Coming up to the second design phase. Under the design phase, we will select the most appropriate structure system. We will see how many kinds of structure system. Alright, in the in the next PPT it is there. First structure analysis, structure design, and then the good for construction drawing. GFC is nothing but the good for construction drawing. It is Sunil, don't do this. Yeah. Good for construction drawing is nothing but the whatever the drawing is on the site we need to follow is plan of the plan which we are using in the site. Okay, and under the construction phases where the resource planning, under the resource planning we have the manpower, material, machinery, and the time. So it is on management. It will be under the management. We will learn the primera for this adoption of the construction technique, and if the changes are there, we can redesign. Guys, if you are not talking, you can mute yourself.
Kindly mute yourself. Like Nawaz, kindly mute your voice.
Okay. So, what kind of structure system we have? So, you guys have studied the two kind of structure system, which is the load bearing and the frame structure. Am I correct? Guys, are you aware with the any third kind of structure system? You can write in the chat box. If you are knowing any other kind of structure system, you can write in the chat box. If you are not knowing, then you can type the no in the chat box. Guys, are you aware with the any other kind of structure system?
Your
Like you
screen
have
is not visible.
is it visible?
Yes, okay.
Yes. So guys, are you aware with the structure system? So basically, we are following the frame and load bearing only, but we have three kind of structure system, and it is also followed in India also. So this frame structure, you all guys are aware with the frame structure, beams, columns, and slab. Okay, we are constructing beams, columns, and slab, and then providing the wood. You are also familiar with the load bearing, which can be constructed by the brick, but this is RC wall load bearing. So this method, like a formwork used in this method, are coming from the Germany. So I have also seen the building in Pune, which was G plus 22, and it was of the RC wall load bearing. It's nothing but the shear wall only. No beams, no columns, only shear wall. So walls has been constructed from the RCC only. So this is new method. And what is the advantage of this? So this kind of building has the long design life. It is around 50 plus year of design life. And drawback of this, it is little bit costly and like a much more CO2 generation because you are using the concrete only, so it will generate the more CO2. But the compared to the other structure system, the durability of this is much large. Okay, so we have the slab system also. So coming to the slab system, so if you are providing the slab directly on the column, so what will happen? Shear will happen. Like when you are providing the paper on the nib of the pen, so the like hole will be there. So directly when you are providing the slab on column, so maybe it is possible that shear failure will be there. So if shear failure is nothing but the when the two equal and opposite forces are acting at that time, shear failure happens. So to stop this shear failure, so you can do one thing, like stress is equal to force by area. So you can decrease the force or you can increase the area. So the decrement of force is not possible because force is constant. So only one thing you can do is increment of area. So how to increase the area? So you can increase the area by two methods. You can increase the area for the slab, or you can increase the area for the column. And the third method is you can increase the area for column as well as you can increase the area for the slab. So you have seen this Chhatrapati Shivaji Airport in the Mumbai. They have also used the flat slab. Okay, and they have provided the column capital. It is nothing but the column capital. If you want to use the drop panel, which is in increment of the slab area, so you can provide the see this drop panel as well as column capital. Waffle or grid slab. So you have seen this kind of structure in the cinema halls. When you want to provide the larger span and you don't want to provide the columns in between, you can use the grid slab system. Okay. Then structure members, you all are aware, columns, beam, slab, foundation, shear wall. Coming up to the column, Indian standard code. So with for the column design, your very first criteria is slenderness ratio. So what is slenderness ratio? Slenderness ratio is nothing but the effective length divided by least lateral dimension. So based on this, we can decide the what will be the length of the column or what will be the least lateral dimension of column. So you can decide the length or width or depth of the column based on the slenderness ratio. Like if you are providing the long column, then what will happen? Then buckle will happen. Okay. So that's why we are using this slenderness ratio for buckling. If slenderness ratio is less than 3, then pedestal. If it is between 3 to 12 short column, between 12 to 16 then long column, and greater than 60, you need to redesign the column. Why redesign the column? Because it will fail under the buckling. Like it will buckle too much. That's why you need to redesign the column. Like if you have the like whole column like this, it will buckle like this. So moment will be also there. That's why you need to redesign the column. And caudal provision for the column, like minimum percentage of reinforcement will be 0.8% of gross area and maximum should be 6. Minimum diameter 12 to avoid the buckling of each. Because if you are using the 8 mm diameter bar, then the buckle will happen. That's why we are using the 12 mm diameter of bar. Minimum number of bar, for each corner there should be one bar. Like for square has a 4 corners, 4 bar. For circular you need to remember 6 bars. For pentagon 5, for octagon 8, like that. Okay. Spacing should be, maximum spacing allowed is 300 mm. Lateral ties, like you are joining the longitudinal bar by the lateral ties. So for the lateral ties, maximum of 6 mm or 0.25 of diameter of long bar. Okay. Then pitch coming up to the, so these all are the beam design. So now I will hand over the session to the Nikun sir. Okay. These all are the, because Nikun sir will also take the 20 minutes, so it will be practical. That's it. So these are the failure of the column, failure of the beam, each and everything. But we will see it later on the regular session. Okay, like which kind of reinforcement you use, which kind of code we should follow. Like in the IS 456, what is there? Then what is analysis? What is design? What is design philosophy? Each and everything we will see during the. So this is nothing but the state flow. For the state flow, this much of topics will be covered. Okay, it is for your first day during the session. Now now I will hand over the session to the Nikun sir.
Make me the host.
Wait. Yes sir. Now you can take.
Good morning to all. This is your second session in which we are going to discuss about the state pro software as well as RCD software and structural drafting methods. So This is our first step. And myself, Nikun Sonagar, MTech in structural engineering and practicing as a structural engineer from last 4 to 5 years. So you can see this is our structural system, and the project was already finished, and all the work will done by my students. So you can see this is our structural system, and this is a factory building. So where we need to take so many clauses, we need to follow all the Indian standard codes, like what is the live load, what is the dead load, and all the load will taken as per the Indian standard code, like IS 456, IS 13920, IS 1893, and IS 875 part 1 or 2. So this is our actual plan. I will show you. This is your plan. I will show you the 3D view also. So you can see this is our actual plan. By using the Staad software, we are going to designing the structure, like what is the importance designing. I will show you the details, like this is our properties. You can see we use plate. I will show you, like you can understand easily. Okay, now it will be easy to show you. So this is our, if you click here as a one property, so they will show the properties where you assign the same properties. So you can see this is the red property for the beam. If you click here, then we can see the dimensions is 0.23 cross 0.45 meter. Another one, this is two columns outside periphery, where we use 230 by 450. Right? And this is also important to provide the size of the column as per Indian standard and as per standard practice. Like if you consider any size, this is not possible to construct at site. So you need to take care during the uses of the size. And you can see here I assign the plate also. And the important thing is that why I assign place only one place rather than all the other load, other areas, because this is very important to analyze the structure. And this is our cantilever portion. So at this area, like I will show you from the top. Just 1 second. Someone some message sending the messages. Okay, this the plate is not visible in current view. So the plate is assigned because we didn't provide any beams here. So that's why we need to put plate here, because rest of the area we assign the floor load. We didn't provide a plate. Plate and floor area both will work same. I will show you. This is our material. We assign the material, and this is our specification. Now the thing is that what is the importance of the specification? You can see. I will highlight the I will highlight. So we can also see the importance of the specification. Why we assign the specification at start and at the end? You can see this is our end portion. This is our actual live project. I will show you the drawing which I sent to the site. So you can see this is our support. This is support, and then next is the loading. So this is our loading condition. So you can see this is our dead load. This is our dead load. This is our negative 3 kilometer per meter. This is our terrace load, where we need to reduce the actual dead load on a wall, because the height of the parapet is less as compared to the rest of the floor. This is a staircase load. You can see here we assign the staircase load. This is also staircase load. This is at a slab level, and this is at a landing level. So we need to assign the two load. This is, you can see, this is our floor load. If it is not very visible, just 1 minute, I will show you in clearly, so you can see the details. Okay, now you can see this is our, if you see the in the green color, this is our slab. You can see this is on the first floor. Same, this is our load. Now this is our plate load. See, if you, this is our live load. So this is our live load at a level of staircase. You can see. Now one important thing that, kindly mute yourself, guys. See, this is a staircase loading. So it will be depending on where your step rests. We need to assign the load only that particular area. You can see I didn't assign the load for all the area, because the stair spanning is only in this area. If I assign to all area, that means the increasing of the reinforcement. This is nothing. So our responsibility is that we need to make a economical structure. So by checking architectural plan, by requirement of architect, we need to assign all the load. Without the knowing, we can do it, we cannot do anything. And this is our rest of the loads. And the load combination we can see in our regular class. Now, after analysis finish, we need to go for the designing part. After giving the design command, we need to do the analysis, and after the analysis, what we need to do, we can find the reinforcement requirement for different structures. So I will show you one example. Like this is our column. Like this is our column. I will click on the column two times. So I will get the reinforcement required is a 994 mm directly from the design part. But now we need to find out the numbers of bar. The state pro also gives the numbers of bar requirement at this section, bar numbers and bar diameter. But what happened here, if you click here, then second, then we can get the 1037. So same reinforcement is here. Like you can see, the requirement is different, but reinforcement is the same. Now you can see here, requirement reinforcement is a 3012. So we need to use 8 numbers of bar and 25 mm diameter bar. But it is not possible. We need to find each and every column. But it is a time taken process. So we don't do this. So we can use the alternative method. Right? I will show you the alternative method also by using the RCDC software. Now I am going to show you the bending moment diagram for the beam. Just 1 minute. I will show you. Right now I will consider only one load cases. I did not consider all the load cases. Okay, just 1 minute. Rest of the time, I will show you the design. Right. This is until the opening of the software. Okay, it will be open. I will show you the beam design. Okay. So now you can see this is movement in Z direction. If you click here and to zoom in the model, I will consider only one beam right now. See, this is our beam. If you click and zoom, so you can get the result, like how much bending moment, how much shear, how much bending moment. The bending moment we need to use for the designing of the that particular beam. So this is the process. Now we'll forward to the RCDC. So this is our RCDC result. This is our column output. You can see the required. You can find the required reinforcement here. So if the, you can see the green column. Green line is that means the column pass, and the red that means our column failed during the design. So we can see the failure diagnosis report, how the column fail and what is the failure characteristic. You can see the column fail into joint shear, right? So we need to check this and we need to set the set and reduce the failure mode, and we can design the optimize. See, this is our joint check. So this is a joint check. That means we need to provide a minimum flexural strength of column, and we need to check shear check at column joint. So this is the two important check that RCDC can give us. So you can see the procedure here. So we can analyze in detail in our regular session. So this is our column design, and now I am going to show you the footing design. You can see this is our footing design. We directly we get the result from this output, so we can save the file and we can use for the sending to the site. You can see we get the pressure check for all the columns. So for each and every column, you can see this is column design table column 1. We get the minimum soil pressure, maximum soil pressure. Same way design table 2, minimum, maximum. So we get all for all the design. Now if you click here the design summary, we will get the required size of the footing, required reinforcement for bottom, top. We get all the things. And this is detailed drawing. You can see here, this is our detailed drawing, which RCTC gave us directly. So we can use this to send through the site. But practically, this is not. Kindly please mute. Practically, this is not useful to send to the site because we need to modify this drawing. So I will show you the drawings. See, this is our first step that we need to provide architecture column layout. So you can see this is the architecture column layout. I mark as issue for checking. See, issue for checking. So we place the column position and send to the architect that they did not problem the columns, right? If architecture give confirmation, then we can start the design. So this is our first step. We design the footing as per you can see the RCDC. This is the output of the RCDC software. So this is our cantilever footing at a property line. So we can design it in our regular session. Or this is our column schedule of column where you can see the size of the column, size of the reinforcement, numbers of the reinforcement, and this is our staircase design. And this is our arrangement of reinforcement. If you did not provide the arrangement of the reinforcement, the on site they will take by themselves, and this is not good for the structure of practice. So we need to provide the, if you see I will explain this one. This is a it four types, four times, right? This is type A. You can see type A. Yes, we can get the type A. That means A means 460. So that means A means 460, and then B means 412 diameter bar. So this is your responsibility to provide the structural all the details to your clients. This is the beam details. This is tie beam details, where we need to provide all the required reinforcement for all the beams by with required dimension also. You can see here I mentioned some dimensions. Then this is our beam design. Sorry, design of the slab with beam. This is structural layout and detailing at ground floor slab level. So you can see this is our beams detail. This is also prepared by my students, and I check all the details. All the work will done by my students. So you can see how much the structural drawing is important during the site work. So as per your requirement and as per your knowledge, you need to learn all the things by consultant. If you learn from any local companies, this is not possible. They did not tell you the preparation of this drawing. But here in my consultancy, like we provide you the drawings that how to prepare this drawing, and at the end of our training, you need to prepare these things with your logos and your consultant name, and you need to submit us that we can see your works and you update yourself, and at the end we will provide you so many projects, so you can able to design the structure by yourself. Yes, Aditya, what happened?
Sir, good morning,
You
sir.
can unmute you. Yes, 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 good morning, good morning.
Yes, sir. I was asking like all these drawings are being prepared through the software matlab,
No, no, no,
directly, or
no.
you have.
Beam did not prepare by software because we need to change so many things in the beam software. Yes, we can prepare it by using RCDC software, but currently we are not using that because they give some additional changes. We need to do it. Like they did not provide like these types of LS. We can say longitudinal section. That means LS. So if we want to like we need to make our theme. So that's why we are going to use these LS. Yes, we can take the reinforcement from the result. But here I
Okay.
do the manual design, like all the design. Like find the bending moment here. Like I will show you. Like by using this moment we calculate the required reinforcement and we directly place it here.
Okay, sir. So means you have taken the data from STAD after analysis, and then you have
Yes, yes,
and
yes,
and then sir you have matlab, altered the data by yourself. What is the
yes,
changes
yes,
required?
yes, 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 yes.
Okay, sir.
And it is not practically possible that we can use the software for all the design. Sometimes you need to do the manual. Sometimes you need to check all the data.
Okay, sir.
Okay,
Acha. Sir,
guys.
yes,
If
sir.
anyone, yes, 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 yes.
Sir, just now you are showing us the reinforcement detailing. Sir, how you have
Yes,
provided
yes.
the ties?
Like I will tell you, Aditya, because we have only 1 to 2 minutes. I will tell
Okay,
you.
sir. Okay, sir.
Okay,
Yes, sir.
okay.
Okay, sir.
Because you have my
One minute,
contact
one minute,
details,
Nikon
so you
sir.
can message
Nikon
me
sir, you can
anytime.
take. Nikon sir, you can take the session because it has increased the time. You can take the session, Nikon sir.
Okay. Yes, Aditya said.
Yes, sir. About the ties in the column, sir.
Tiles can be designing by the RCDC also. You can see here RCDC give you the tile details. You can see here ductile
Yes,
tiles,
sir.
ductile links,
Yes, sir.
2 diameter 150 mm center, 10 mm diameter the 50 mm center center. So we will get the tiles. We can each and everything we can design from RCDC.
Okay, sir.
Staircase also designing by RCDC.
Yes, sir. Got my answer.
Okay,
Thank you, sir.
thank you. Guys, if anyone have any query, then you can unmute yourself and ask your queries related to state pro, related to RCDC, as well as the drawing. Okay, Darpan sir, I think all understand all the procedures.
Yes, guys. So, guys, we will start our session from the tomorrow itself. So guys, like if anyone interested to, like, it was a demo lecture, so as per my knowledge, you have not
Yes,
enrolled for the
someone
internship.
raised.
Yes guys, if you are interested to for the internship, so you guys can send the message to Nikon sir as well as to the me. Okay, and we are starting from the tomorrow, and it will be take for the two
Sheikh
months.
Jilan. Yes, Jilan, what you want to say? Please unmute yourself and you can say. Jilan, I did not hear your voice. No, no, you mute yourself. No, 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 we didn't hear you.
You can write in the chat
Okay,
box.
kindly, you
You can
can
write in the chat.
write the chat box.
Write in the chat box.
Select the properties. We use the different size of the column and beam. Yes, yes, we can use the different size of the column and different size of the beam. Okay, this is old messages.
Okay, guys. So we are ending the meeting here. Okay.
Jilan, you can message me. You have already my contact details, so you can directly message me.
Yes. You can contact us for more. Okay. So guys, thank you so much for being with us, and we are ending the meeting here. Nikul sir, please end the meeting.
Okay, thank you guys. Thank you so much for participate here. Now you can check that
Thank you,
if
sir.
you want to learn all the things like preparation of the drawings, structural drawings like Staad Pro models and RCDC models. So you can contact us, and our batch started by tomorrow mornings, and possibility it will be completed in 1 to 2 months. Like maximum we will take 2.5 months. So if you want to interested to join and start your career in structural engineering designing, so kindly contact us as soon as possible. Jilan, you can message me, okay? I will answer you.